Hi everyone. For 14.2, we're going to talk about congruent triangles. So basically, Module 14 is all about triangles, and we talked about some angle theorems in triangles yesterday in 14.1, and now we're going to talk about what it means for triangles to be congruent. Now remember, the word congruent is two shapes that are exactly the same. So two triangles are congruent if they are the exact same triangle, but usually kind of in a different place. And maybe one of them is rotated so they don't look exactly the same, but one way or another they are exactly the same. Now what we like to say is corresponding parts of congruent triangles are congruent. Now sometimes in a geometry class, like we're doing right now, we'll use the first letter of each thing, C, P, C, T, C. This is actually a theorem that says corresponding parts of congruent triangles are congruent, and you might hear somebody say that, those letters, CPCTC. What that means is exactly that. Now what that phrase means is that each angle of one of the triangles matches up with one in the other triangle, and each side of one of the triangles matches up with one from the other. So let me give you a picture and show you exactly what that means. These two triangles here are congruent. Now the way I know that is because they're all marked up. So you can see that each angle of one is congruent to each angle of the other. So I said right here, the first thing I noticed is angle B is congruent to angle E. Well, that's because there's one mark on each one. Angle B congruent to angle E. And then I said also angle A is congruent to angle D because there's two marks. 1, 2 on A, 1, 2 on D. And then the last one, angle C is congruent to angle F because you can see there are three little arcs on each one. So each of the three angles of one triangle is congruent to each of the three angles of the other one. But then the same thing is true for the sides. So for the sides, right here I have AB, line segment AB is congruent to DE. That's because they each have one little marker on them. And then line segment AC is congruent to DF. AC is here, DF is here, they each have two. And then finally the third one, BC and EF, each have three, here and here. So that's what we mean when we say corresponding parts of congruent triangles are congruent. Corresponding means one from each. So if every side from one triangle is congruent to each side of the other, and the same for the angles, then we say the triangles are congruent. Now that's going to lead us to what's called a congruence statement. And it's exactly what it sounds like. It's a statement that says two things are congruent. For example, I could say, and what you see in green right there, it says that the little triangle symbol means triangle, of course. So it says triangle PQR. So that would be a triangle where the three vertices, remember vertices is plural for vertex, the 3 points that make up the triangle are points P, Q, and R. And I could say triangle PQR is congruent to triangle XYZ. Now, what's important for a congruent statement is that you don't just throw the letters in there. You don't just say like, okay, well there's a triangle ABC, there's a triangle, RST, they're congruent, so I'm just going to throw the letters in there. The letters have to match up. And what I mean by match up is when I say the first letter here is P and the first letter here is X, those two angles have to be a match. Those have to be congruent. And when my middle letter here is Q and my middle letter here is Y, those ones have to be a match. And then finally, if my third letter here is R and my third letter here is Z, those have to be a match. So you can't just throw them in order. A lot of times we put things automatically in alphabetical order, P, Q, R, X, Y, Z. Well, if the angles don't match up that way, that may not be the right congruent statement. If angle P is actually congruent to angle Z, then Z needs to go first in your second triangle. So it's easy to do a congruent statement. It's just saying two triangles are congruent, but you do have to make sure the letters match up. So let's write a congruent statement for the triangles here. So let's say they are congruent. I didn't mark the angles, but let's say they're congruent. Let's say for now that's enough. And it's also not really drawn to scale, maybe. Maybe it is, but it's kind of twisted, and one of them's flipped, one of them is reflected. But we can figure this out. So I'm going to write a congruent statement. I'm going to say triangle something is congruent to triangle something else. Now here's the thing. For the first one, you can pick either triangle and name it in any order you want. It doesn't matter. So like I might go alphabetical on the first one and call the first triangle BCD. Because the first one you call whatever you want, it doesn't matter. I could also start with the second one. I could start with triangle XYZ. I could go out of order and call the first one triangle DCB. It doesn't matter. Just pick one of them and name it. Then you say is congruent to triangle, and now here's where we're going to slow it down and be more careful. So I want to see what angle matches up with B. Well, see, the angles aren't marked on this, and I did that on purpose just to make it so it wasn't quite as obvious. If there was one little marker on B, one arc, it's real easy to see what it matches up with the other one. Now, if you can't do that, we can still figure it out, because if I'm looking at this picture, I notice angle B is made up by these two sides here, the one with one little marker and the one with two. Well, if I find those same two sides on this triangle and look at the angle between them, B matches up with Z. So the first letter here has to be Z. And you can see with everything circled in red why that is. The angle B is in between the two sides that have 1 and 2 markers on them, and so is angle Z. Okay, now let's do the same thing. Let's get rid of this. And now let's do the same thing for angle C. Because see, C is my second letter here. So I want to see what the second letter is on my other one. Well, C is made up of the sides that have 2 and 3 markers. So here's 2, here's 3, in between those is Y. So my second letter here has to be Y. And again, when it's all circled in red, it makes it nice and obvious there. You're matching up angles that have to be the same. Now the last one, you don't really have to do. You don't have to match up. There's only one letter left. It's X. So I'm just going to put the X in there. Although, if you really wanted to see it, you're trying to match up with D. D is between the 1 and the 3. The 1 is here, the 3 is here, so D matches up with X. But just be careful when you're doing that. When you're writing a congruent statement, a lot of people would take this question, go too quickly, and just say, put everything in alphabetical order. Triangle BCD is congruent to triangle XYZ, and they'd move on to the next question. That's a wrong statement. That's an incorrect statement. Triangle BCD is not congruent to triangle XYZ. It's congruent to triangle ZYX because each letter has to match up. So be careful when you're writing your congruent statement. Make sure the angles and the letters match up. And then here's the other type of question we're going to do today. Let's do a solve for X question. It's actually a solve for X and Y question. This one has both an X and a Y in it. We're going to solve for both. And I told you in the question that the triangles are congruent. Triangle ABC is congruent to triangle DEF. So I look at it, and let's decide what we want to do first. Let's say I want to solve for Y first. And I see this 2Y minus 5 right here. I say 2y minus 5 is angle D. Let's go back to the congruent statement and see what angle D matches up with. Angle D is the first letter here, so it matches up with angle A from this triangle, which is 65. Now, if those two angles are congruent, which they are, then those two things are equal, and that's our first equation to solve. So I'm going to take the 2y minus 5 equals 65. I took the two things I circled because I know they're equal. I set them equal to each other. I'm going to solve for y. So let's do that. To solve for y, the first thing I would do is use a plus 5 to cancel out that minus 5. Same thing on both sides. 5's are gone, leaves just 2y. 65 plus 5 is 70. And then we'll cancel out the 2 by dividing both sides by 2. And 70 divided by 2 is 35. So y is 35. That's the first part of your answer. But see, what happens is we also needed to know that to do the second part of our answer. Because if you look over here, that side, EF, line segment EF, was 2x plus y. You can't solve for something that has two different variables in it. So what I had to do is solve for y first, plug it in. See, now this side right here is 2x plus 35. And let's go back to our picture. Let's take some of this clutter out here. Go back to a blank picture here. And if I want to use the side 2x plus 35, that's line segment EF. Now line segment EF is the last two letters in this triangle here, which means it matches up with the last two letters in this one here. That's B to C, which is 90.6. So that's going to be my second equation. The two things that are circled are equal again. I use the congruent statement to match up equal parts. My second equation here is going to be 2x plus 35 equals 90.6. And we have some decimals, but that's okay. We'll end up using a calculator for this. Maybe. So let's subtract 35 from both sides. Those are gone. It leaves just the 2x. Let's see here. 54.6? No, 55.6. Yeah. And then we will divide that by 2. Let's see. I want to try and do this one in my head. What was that? 27.8. I think x ends up being 27.8. We can double check that in a calculator and make sure. But you get the idea. The way we set up the question was the important part. Each time I looked at the congruent statement and I looked for two things that were equal. In the first part, the two things that were equal, I'll recircle it now in green, are those two things right there. So that was my first equation. 2y minus 5 equals 65. Now for the second one, the two things that were equal were the two things I circled in red. Let's get rid of those. Those are also equal, so that was my second equation. But that one had to go second. I couldn't do that one first because I needed to know what y equaled first. But then you solve each one. We did what we were asked to. We solve for x, we solve for y. And it all has to do with understanding corresponding parts of congruent triangles are congruent. If you know how the two triangles match up, there are 6 different congruent things in every triangle. 3 angles, 3 sides, 6 different pairs of congruent things.